Remember when you learned to find derivatives, we first learned how to take the derivative of basic functions, right? We learned the power rule. We learned how to find the derivative of e to the x or natural log of x, and we learned sine and cosine. And then we learned to take derivatives of more complex functions. Like for example, if we have the composition of two functions, we can use the chain rule. If we have the product of two functions, we can use the product rule. If we have a quotient of two functions, we can use the quotient rule. And now we're going to do a similar thing with integrals. We've learned how to take the integrals of basic functions, and now we're going to learn how to take integrals of more complex functions. And the first thing that we're going to do is look at reversing the chain rule. Okay, so before we get started on that, let's take a look again at the chain rule. So the chain rule is used when we have a composition of functions. So we have an outside function and an inside function. So if we're trying to take the derivative of f of g of x, right, we would consider g of x to be the inside function and f to be the outside function. And to find the derivative of this composition of functions, we take the derivative of the outside function, leave the inside function as it is, and multiply it times the derivative of the inside function. All right, so let's use the chain rule. In example 1, we're going to use the chain rule and then look at the corresponding indefinite integral. All right, so in this first function, we've got e to the x squared. All right, so our outside function is the e to the x function. The inside function is x squared. All right, so let's look at the derivative of this function using the chain rule. Right, so we take the derivative of the outside function, right? The derivative of e to the x is e to the x. And we could break this apart, I guess, if we wanted to, and call this e to the z, where z is equal to x squared, right? So the derivative of e to the z is e to the z, and z is x squared. So the derivative of the outside function is just going to be e to the x squared, and then we take that times the derivative of the inside function, which is the x squared function. And the derivative of x squared is just 2x. So if we want to write the corresponding indefinite integral, we're going to write the integral of this derivative, right? E to the x squared times 2x dx is equal to e to the x squared plus c, right? Because we know that if we take the derivative of e to the x squared plus c, we would get e to the x squared times 2x. All right? All right, let's take a look at another one. All right, here we have f of x is equal to 1/6 times the quantity x squared plus 1 to the 6th power. All right, let's find f prime of x. All right, the derivative of this function. So we just got 1/6, and the outside function is a power function, right? We've got this x squared plus 1 to the 6th power. All right, so we can take the derivative of the outside function, so we bring down the 6, and then reduce the power. All right, so we're going to make that to the 5th power, and we're going to leave the inside function alone. And now we have to take it times the derivative of the inside function, which is 2x. All right, now I can simplify that a little bit because 1/6 of 6 is just 1. All right, so the corresponding indefinite integral is the integral of this derivative, right, which is, let's see, x squared plus 1 to the 5th times 2x dx is equal to the original function, right? So it's going to be 1/6 x squared plus 1 to the 6th plus c. All right. So notice, when you see an integral and you see the inside, you can kind of see the derivative of the inside function appearing here, right? So that's kind of a clue with these problems that we're going to be working on. But let's keep going here. Let's take a look at the next function. I'm going to take the derivative of this natural log of x squared plus 4. All right, so the outside function is a natural log. So f prime of x is the derivative of the outside function, which is going to be 1 over whatever's inside here. So we're going to leave the inside function alone. And then we take it times the derivative of the inside function, which is again just 2x. All right. So what's the corresponding indefinite integral? So if this is true, then we know that the integral of this derivative, right, the antiderivative of the derivative should give us the original function. So we got 1 over x squared plus 4 times 2x dx is equal to the natural log of x squared plus 4 plus c. All right, that's the corresponding indefinite integral. All right, one more. Take the derivative of the sine function. All right, so f prime of x, the derivative of sine is cosine. So cosine, we'll leave the inside function alone. So x squared minus pi over 2. And then we take it times the derivative of the inside function, which is again 2x. So the corresponding indefinite integral, if we take the integral, the antiderivative of the derivative, we'll get back the function that we had in the first place. So the integral of cosine of x squared minus pi over 2 times 2x dx is equal to sine of x squared minus pi over 2 plus c. All right, so all we're doing there was we're just using the chain rule to find the derivative. And then the corresponding indefinite integral, if we're looking for the antiderivative of the derivative, we should get the function we had back. Okay? All right. So in general, there's something called the method of substitution. And what we're looking for is an inside function and an outside function. Now, I think I'm going to cover this in the next video, so I'll meet you there.